Hi, welcome to Orozco's Lectures. I am Jose Orozco, and these are my lectures. This lecture is a pre-calculus lecture. I hope you enjoy it.
This is chapter 2, which is on polynomial and rational functions. So we started with 2.1, which is on quadratic functions. And models. All right, let's make that look cleaner. There we go. So we're going to start with a definition here. And this definition is for a polynomial function. And essentially it says if we have f of x being in the form of a polynomial, for example, a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus a sub n minus 2 x to the n minus 2, so on and so forth, down to a sub 2x squared plus a sub 1x plus a naught. All right, and we've got something like this. This is a polynomial function of degree n. All right, that's what tells us the degree, the nth degree. In here, assuming that a sub n is not equal to 0. All right, if a sub n were equal to 0, well, then this term right here wouldn't exist. So now in here, a sub n is called the leading coefficient. And this last term over here, the one that doesn't have a variable, that's called, so a naught is called the constant term. All right, so a little bit of nomenclature there. Now let's specifically talk about quadratic functions. Here, well, a quadratic function is one who follows a quadratic polynomial. So ax squared plus bx plus c. Right in here, a should not be equal to 0. So our leading coefficient a should not be equal to 0 because then this term wouldn't be there and we would just have a linear function. But as written, that is a quadratic function. Now we know what these look like, right? This gives us parabolas, right? And depending on our leading coefficient a here, if our leading coefficient is positive, then we've got some sort of parabola facing upwards, right? If our leading coefficient is negative, then we've got some parabola opening up downwards. Now, in here, in these parabolas, if we have it in this form of ax squared plus bx plus c, well, then we have that our vertex is at the point of negative b over 2a, comma, f of negative b over 2a. All right, and that implies then that our axis of symmetry would be at x equals negative b over 2a. All right, now because this is our axis of symmetry, well, that tells us that that's where it would be symmetrical about, right? So something like that. All right, now we've spoken about quadratic functions before, right? But we spoke about them in this format, in the vertex format. So the vertex form of a quadratic function is f of x is equal to a times x minus h squared plus k, and here the vertex is at the point h comma k, and the axis of symmetry is at x is equal to h. So in here, what I want you to notice now is that this actually implies that h is equal to negative b over 2a, and k would then be equal to f of negative b over 2a, right? Because it's in the same spots as this over here, all right? So that's useful in general to put things into quadratic form, into the vertex form, excuse me. So now let's do an example where we sketch some of this, all right? So let's say I just said sketch f of x is equal to 3x squared plus 6x plus 4, right? By first putting it by rewriting in vertex form. All right. So in here, well, essentially what I'm saying here by rewriting it in vertex form, what I'm saying is I want f of x is equal to a times x minus h squared plus k, right? Right now, it's in polynomial form, like an expanded polynomial. So what do? Well, we know that we need to complete the square. So let's complete the square. All right, so in here, we're going to say, well, f of x was given to be 3x squared plus 6x plus 4, right? We can rewrite this if I factor out a 3 out of the first two terms. I can rewrite this now as 3 times x squared plus 2x plus 4. At that point, I could complete the square. So what I'm going to do here is I'm going to take this right here to be a beta. I set that equal to 2, but I don't care about that right now. I care about beta over 2, which happens to be 1. But what I really care about is beta over 2 squared, which is also 1. And what we're going to do with that is we're going to add 0. So we have 3 times x squared plus 2x, and here's where we add 0 plus 1 minus 1, right? That's just adding 0. And then that plus 4. Take the negative 1 out of there. So we have here 3 times x squared plus 2x plus 1. To take that negative 1 out here, we need to multiply it by that 3. So we have negative 3 plus 4. Finally, these three terms will always factor to something squared. And what that something is the variable you're working with and your beta over 2. So plus 1. And negative 3 plus 4 is 1. So plus 1, right? So now that we completed the square, now we have it in vertex form. All right, and since I need to sketch, I also need to find some intercepts, right? Well, some other things about here. First, actually, before the intercepts, let's say that we have, from here, we can say that our axis of symmetry is x equals h, right? X equals h. So in this case, this implies that, so our axis of symmetry, that is x is equal to negative 1, right? Because I need minus h, so this is minus negative 1. All right, and this also tells me that my vertex is at the point negative 1 comma positive 1, right? Because there's my k right there. And my a, my leading coefficient, was 3, right? So this is greater than 0, which tells me that we have it opening upwards. The last couple of things that we need here are the intercepts so that we can sketch this. So let's see, the x-intercept is when y is equal to 0. So I'm going to say we have 3 times x plus 1 squared plus 1. Set that equal to 0. Move the 1 over as well as the 3. End up with x plus 1 quantity squared is equal to negative 1/3. And this has no solution. Let me rephrase that. It has no real solution, all right? Because the solution would not be a real number. And when we're sketching, we're only considering the real numbers. So in here, this has no real solution, which tells us that it has no x-intercept. Let's rewrite that. No x-intercept, all right? Now, let's look for the y-intercept. The y-intercept is when x is equal to 0. But that's super easy because it is just this last value over here, right? Plug in 0, these go away, and I end up with just 4. So I end up with y is equal to 4. There we go. And that is the coordinate 0, 4. So now that we've got that, we can go ahead and sketch this. We've got all the information that we need. So let's see. We know that, let's make that a bit lower. We know that our vertex is at negative 1, 1, right? Which actually before that, our axis of symmetry is at x equals 1. Excuse me, yeah, negative 1. X equals negative 1. So there it is. That's our axis of symmetry, x equals negative 1. And we've got our vertex at negative 1, 1. So let's say that's at the height of 1. So our vertex is negative 1, comma 1. And what else do we have? We know it opens upwards. Okay. We have our x-intercept being 0, 4. So 0, 4 would be, let's say this is 4. Obviously not drawn to scale. So that's our x-intercept. And now to go ahead and sketch this, we would say, well, let's just make this look like a parabola. Oh, going through the point. There we go. So something like that. All right. And yeah. Now, notice again here that I'm doing a sketch. It's just what's it showing? Just some general points, like the intercepts. Here I have the y-intercept. I looked for the x-intercepts, but there were none, so I didn't label them. But I did label the vertex as well as the axis of symmetry. All right, so that's the kind of thing that you want to include in your sketch. All right, let's do another one. B. So B. Let's say that we have f of x is equal to negative 2x squared plus 7x minus 3. And that's a 3. There we go. All right, so here we're going to sketch this, right? Sketch. So, all right, well, we know that we can complete the square, right? We know how to complete the square, but we also know, but we just found out some other stuff. We found out that the vertex could also be written as negative b over 2a, comma, f of negative b over 2a, and that this was the same as saying h, comma, k. So what we can do here is, let's go and figure out what h is. H being equal to negative b over 2a, in this case would be the negative of 7 over 2 times negative 2, which gives us a positive 7/4. All right. What else do we know? We know that k is f of negative b over 2a. So in this case would be negative 2 times 7/4 squared plus 7 times 7/4 minus 3, which gives me, well, 7/4 squared is 49/16. 7 times 7/4 is 49/4. We have that minus 3. Finally here, this is negative 49/8, right? Plus 49/4 minus 3, and that's a minus. And the next thing I notice here is that this is twice as big as this. All right, so let's look at that for a second. Just a little real quick way of adding these fractions. So we have 49/4 minus 49/8. The common denominator is 8. So to go from 4 to 8, multiply by 2. So I have 2 times 49 minus 49. And here, you don't really need to do the arithmetic. Think of this as 2 apples minus 1 apple. That just gives me 1 apple. So what I get here is just 49/8. All right. You could have done 2 times 49 is 98. 98 minus 49 is 49. But I think this is a little quicker to think about it that way. Now, from there, well, that's just these two, right? So I have 49/8 minus 3. But 3 in terms of 8 is 24, right? So minus 24/8, and then 49 minus 24, well, that's simply 25. So 25/8. So that's my value of k. So what I can say now is that f of x is equal to our a, which was -2 times x minus h. H was 7/4, so x minus 7/4, and that's 4. There we go, squared, plus our k value, which was 25/8. All right. So that's another way to complete the square, specifically for graphing quadratic functions. From there, what we can say is that our a is less than 0. Our axis of symmetry, let's rewrite that. Our a being equal to -2, which is less than 0, means we have a parabola facing landwards. Our axis of symmetry is x is equal to 7/4, and our vertex is at 7/4, comma 25/8. The next few things that we can figure out here are our intercepts. So we start with our x-intercept is where y is equal to 0. So I'm going to set this whole thing, -2 times x minus 7/4 squared plus 25/8 equal to 0. So we can do that. And to do that, well, we say, well, move this to the other side. So I have -2 times x minus 7/4 squared is equal to -25/8. Divide both sides here by -2. So that gives me x minus 7/4 squared is equal to, well, negative divided by a negative is positive, but then 25/8 divided by 2 is the same as multiplying by 1/2. So we have 25/16. Take the square root of both sides, so x minus 7/4 is equal to plus or minus the square root of this thing. So the square root of 25 is 5, the square root of 16 is 4, giving us that x is equal to negative, well, not negative anymore because we moved it to the other side, positive 7/4 plus or minus 5/4, which gives us two versions, right? The plus or minus. So the plus 7 plus 5/4 is 12/4, which is equal to 3. And then 7 minus 4/4 is equal to 3/4, right? Now, from there, well, what does that give us? That gives us the point 3, 0 and the point 3/4, 0 as our x-intercepts. And we should also be looking for y-intercepts. So let's say the y-intercept is where x is equal to 0. So essentially I'm looking for f of 0, which is very simple in this case. We don't even have to work on this one. We can go back to the original function, and there it is. It's -3, right? Because this goes to 0 and that goes to 0. So it's just -3, giving us the point 0, -3. And at that point, now we've got everything we need to sketch. So let's go ahead and sketch this. And what do we know about this? We've got our axis of symmetry being 7/4. So let's start with that. Let's say that this right here is our axis of symmetry being x is equal to 7/4. Our vertex is 7/4, 25/8. So let's say that this right here is 25, not 55, 25/8. That's a vertex, which again is at 7/4, 25/8. We have our y-intercept as 0, -3. So let's sketch that. 0, -3, let's say that's right here, right? That's at -3. And lastly, well, let's go ahead and draw label our x-intercepts. So we have one here at around 3/4, and then another one over here at 3. Lastly, we draw our parabola. something like that. All right. We can draw that a little bit better. Nope, apparently we can't. Okay. That's a parabola facing landwards. All right. So now, next thing I want to talk about is something called, well, actually, we want to do another kind of example. Let's say that, write the standard equation of a parabola whose vertex is -4, 11 and passes through the point -6, 15. All right. So let's see what happens here. So what we want is to come up with a parabola. Well, we know that a parabola in vertex form is f of x is equal to a times x minus h squared plus k, where the vertex is h comma k, right? But in here, we're told what the vertex is. We're told it's -4, 11. So what we can say now is that this tells us that f of x is equal to a times x minus -4, right? That's our h, squared plus 11. Then what else do we know about this? We've got a point here, -6, 15. All right. And what does that tell us? Well, that tells us that when x is equal to -6, when we plug in -6, our y value should be 15. So what does that give us? Well, actually, first let's simplify this. This is just a times x plus 4 squared plus 11, right? All right, so now let's use this. So f of -6, in other words, a times -6 plus 4 squared plus 11 is supposed to give me a value of 15. And the idea here is to solve for a. So what does this give us? This gives us a times -2 plus, -6 plus 4 is -2, so -2 squared plus 11. Well, let's move that 11 to the other side. 15 minus 11 is 4. -2 squared is 4, so we have 4a is equal to 4, giving us that a is equal to 1. So in this case, well, what does that tell us now? That tells us that f of x is equal to a, which is just 1. We don't normally write the 1 when we're multiplying. So it's just x plus 4 squared plus 11. All right? And that's our vertex form. Now, if we really wanted to, we could expand this. We would say this is x squared plus 8x plus 16 plus 11, right? Just expanded this, giving me my final answer of x squared plus 8x plus 27. All right. There's another one. So that was C. D. Let's say now that I told you that same instructions, but now the vertex is at 5, -3, and the point that it passes through is -7, -10. All right. Well, in here we start the same exact way. We know that the vertex form of a parabola is a times x minus h squared plus k, and in this case it will be a times x minus 3 squared, what? No, x minus 5 squared, there we go, h, this is h, k, minus 3, right, because k is -3. So at that point, let's see, what else do we know? We know that when we plug in -7, we get the value of -10. Okay, so f of -7 is a times -7 minus 5 squared minus 3, which gives us a times -12 squared minus 3, and this right here is supposed to be equal to -10, right? when we plug it in, we're supposed to get negative 10. So solving for a here, well, add 3 to both sides. So I have negative 12 squared is 144a. Add 3 to both sides. I end up with negative 7. So that a is just simply negative 7 over 144. Which now, this tells us that our final answer in vertex form, it would be our a value, negative 7 over 144 times x minus 5 squared minus 3. And I'm going to leave that one in that format. All right, now, the next thing I want to talk about is something called the quadratic formula. This is quadratic. All right, and in here, you probably have heard of the quadratic formula in the past, but let's see where it comes from. So in here, so given ax squared plus bx plus c is equal to 0, x can be found to be negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, the question here is how? Right? This is true, but how is this possible? Well, let's see. If I start with ax squared plus bx, so this is our proof. If I start with ax squared plus bx plus c is equal to 0, I can complete the square here, and I'm left with x squared plus b over ax plus c is equal to 0, right? I factored out the a from the first two terms. In there, I'm going to say, well, let my beta be equal to b over a, right here. And what I care about is beta over 2, which is b over 2a. And what I care about more right now is b over 2 squared, which would be b squared over 4a squared. And I'm going to use that to add 0. So I have a times x squared plus b over ax. And here's where I add 0 plus b squared over 4a squared minus b squared over 4a squared. And that plus c is equal to 0. Next thing I want to do is take this piece outside of the parentheses, but I need to distribute the a to it. So I have x squared plus b over ax plus b squared over 4a squared. Putting this outside, it's still negative b squared over 4a. And it's just 4a because this a was distributed to it. And then that plus c is equal to 0. Next thing I'm going to do here is I'm going to factor these three. And if you recall, those always factor to something squared. The variable you're working with and your beta over 2. In this case, it's just a positive b over 2a. So plus b over 2a. And then we have a minus b squared over 4a. You know what? Let's move those to the other side. I'm going to move these two to the other side. So what I have is equal to a positive b squared over 4a and then minus c. The next thing I'm going to do is I'm going to come up with a common denominator for those values on the right, and that is 4a. So I end up with b squared minus, right, because in here what I'm doing is I'm multiplying this by 4a over 4a, so that I can end up here with minus 4ac. Divide both sides by a, so I have here x plus b over 2a squared is equal to b squared minus 4ac over 4a squared, right? Putting this on the bottom over here. Giving me now, if I take the square root of both sides, x plus b over 2a is equal to, well, taking the square root of an equation, so plus or minus the square root of the top, so b squared minus 4ac, over the square root of the bottom. The square root of 4 is 2, the square root of a squared is just a. So this gives me now my final answer of x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. But as you'll note, they're both over 2a. So what we can do is just rewrite this all over 2a. All right. Now, how is this also helpful? Well, notice what this is doing is taking the quadratic function, this means the quadratic polynomial, and set it equal to 0. Well, this is equivalent to saying the x-intercepts of a quadratic function. All right, this statement right here. So if we had done that here to find the x-intercept, we could have, instead of using this vertex form, we could have actually gone and used this form by using the quadratic formula. All right. Similarly, in the previous one, we could have used this to find the quadratic formula, but you would have found that this region over here of the quadratic formula, the b squared minus 4ac, would have been negative, which would not give you a real solution. Now, another thing about that I want to talk about here is the min and the max of a parabola. All right. So the min and max of a parabola, it happens at its vertex. So if I say given f of x is ax is equal to ax squared plus bx plus c, right? Where a is not equal to 0. In other words, I'm forcing it to be a quadratic. So given a quadratic function, the vertex or the min or max value of f happens at its vertex. In other words, at the point negative b over 2a, comma, f of negative b over 2a. All right. Now, if a is greater than 0, so if we have a positive leading coefficient, we know it's this, so this would give us a minimum, right? And if a is less than 0, we would have a vertex facing downwards like that, which would give us a maximum. All right. So now let's apply this. Let's do a word problem. So I believe I'm at letter E. I'm not sure. All right. So now the path of a baseball being hit is given by f of x is equal to negative 0.007 x squared plus x plus 4, where f of x is the height of the ball in feet, and x is the horizontal distance from home plate. Also in feet. All right. So we're gonna ask two questions here. The first question is, so question 1 is, what is the maximum height of the ball? And the second question we're gonna ask here is, how far from home plate does the ball hit the ground? So the very first question, what is the maximum height of the ball? Well, the thing to notice here is that we're working with a quadratic function, right? And because we're working with a quadratic function, we're working with a parabola, and we just spoke about how to find the maximum and minimum values of a parabola, so it would happen at its vertex. So for question 1, really what it's saying is find the vertex. All right. So what we're going to say is, well, the vertex happens at negative b over 2a, comma, f of negative b over 2a. In this case, well, what is negative b over 2a? So we're going to have, so negative b over 2a is equal to the negative of b, which is just 1, over 2 times 0.007. All right. And, well, 2 times 7 is 14, so we have negative 1 over 0.014, right? But this is just 14 thousandths, so it's negative 1 over 14 thousandths, which can be rewritten as, well, divided by a fraction multiplied by the reciprocal, so negative 1,000 over 14, which reduces to negative 500 over 7. And I missed something here. Look at that. So it's a negative 0.007. So this should be negative, this should be negative, and at that point, negative or negative is positive. There we go. I fixed it. Good job. Now, so that's our the x value of the vertex. But the question was, what is the maximum value, right? The maximum value would technically be, so the maximum height here, it would be this, you would have to use the y value of the vertex. So what we're going to do is figure out what f of 500 over 7 is. So we have f of 500 over 7, which would be, well, remember it was negative 0.07 times 500 over 7 squared plus 500 over 7. And what was the rest of this? Plus 4. Okay. Plus 4. All right. Now, to work here in general, decimals are awful. Don't work with decimals. So let's rewrite this as negative 7 over 1,000. So that's negative 7 over 1,000 times 500 over 7 squared. Well, 7 squared is just 49. 500 squared, well, 5 squared is 25. And then double the amount of zeros. So 1, 2, 3, 4. So 250,000. Plus 500 over 7. And then that plus 4. All right. What does that give us? Well, let's see. We can reduce a little bit here. This 1,000 gets rid of 1,000 of those. This 7 goes into itself once, into 49 7 times. So what we've got here is negative 250 over 7 plus 500 over 7 plus, well, these are both over 7, so I'm going to put 4 over 7. So 28 over 7. Negative 250 plus 500. Well, it's 250 because it's twice as much as that, right? So 250 plus 28 sevenths is 278 over 7, which is approximately, so 278 divided by 7, 39.71 feet, right? Because we were told to give that our function was in terms of feet, all right? So that is the maximum height of the ball. The second question is, how far from home plate does the ball hit the ground? So let's visualize what we're saying here. How far from home plate? Well, this is essentially what the parabola looks like, right? Where this right here is at the height that the batter hits the ball. And this is my awesomely drawn bat and ball. All right, so what we're looking for is, what is this value? What we found in part A, just to be clear, was this value. So we found that that was 39.71 feet. What we're looking for here in part B, or in part 2, is this distance. What is that? So, well, let's think about it. In this little pseudograph here, what are we really looking for? This right here can be considered an x-intercept. So what we're really asking for here is the x-intercept. Now, technically, there's going to be another one over here, all right, from this parabola. But we'll discuss why we'll ignore that value. So now let's find the x-intercept. So the x-intercept is when y is equal to 0. So in here we have negative 0.007. Well, let's actually, you know what, let's write that back as a fraction. So 7/1000 x squared plus x plus 4, set it equal to 0. All right. In here, the very first thing I'm going to do here to not work with this fraction is I'm going to multiply everything by 1,000. So I have negative 7x squared plus 1,000 x plus 4,000 is equal to 0. And this is what I'm going to be solving now. Now, in here, if this is factorable, it's going to take me too long to figure out. So I'm not going to try to factor this. I'm also not going to try to complete the square just because of the ugly numbers on it. But what we can do is use the quadratic formula, which, if you recall, was x is equal to negative b plus or minus the square root of b squared minus 4ac, all of it over 2a. So in this case, we have the negative of b, which is 1,000, plus or minus the square root of 1,000 squared minus 4 times negative 7 times 4,000. Right? And then all of this over 2 times a, which is negative 7. So what does that give us? This gives us now negative 1,000 plus or minus the square root of 1,000 squared is, well, 6 zeros. 1, 2, 3, 4, 5, 6. So 1 million. Negative times a negative is a positive. 4 times 4 is 16. And then 16 times 7 is 112. So we have 112,000. All of this over 2 times negative 7 is negative 14. Now, in this case, we end up with 1 million plus 112,000. So it's 1,112,000. All of that over negative 14. At this point, I'm just going to go ahead and plug this into the calculator to see what we get. So first I'm going to do the positive and then the negative. So the positive and then the negative. So in other words, the part where I add and the part where I subtract. So when I plugged that into the calculator, I ended up with negative 3.89. And when I plug the minus into here, I ended up with 146.75. And these are both in feet. But let's see what happened here. This one over here will be the negative value. We're going to ignore that. Now, why are we going to ignore that? Well, because it doesn't make sense in the terms of our problem, right? In our problem, the ball was thrown and then hit, which is what created that parabola. So that's why this is the only possible solution over here. All right. So when does the ball, or how far from home does this hit the ground? At 146.75 feet. And that is the end of 2.1.
Wasn't that fun? If you think I made a mistake somewhere, you're probably right. Tell me all about it in the comments. If you feel you learned something from me in this video, hit the like button, hit the subscribe button, but more importantly, share it. Share this video with your classmates. And remember, you don't have to like math in order to be good at it. But you do have to be good at it. I am Jose Orozco. Goodbye.